lots of practice. While we've done lots of practicing and have a tech team behind us, technology is not perfect. If Zoom fails at any point, try to log back in. And if that doesn't work, we'll send instructions through the Socio app, our event platform. Okay, now onto the program that you've been waiting for. Today's Alumni College session, Protecting the Planet Through Science, Policy, and Law, will run for 90 minutes. Our presenters have prepared 60 minutes of presentation and will leave us 30 minutes for Q&A at the end. So let's jump in. I'm honored to introduce Susan Smith, class of 1976, and Chet Koblinsky, class of 1971. Susan teaches environmental, energy, and natural resources law at Willamette University, directing the law school's certificate in sustainability and environmental justice. Her current research focuses on water justice ethics, governance, and law. Her litigation experience includes several decades representing environmental and community groups pro bono, defending EPA and other federal agencies at justice, and prosecuting environmental crimes for the state of Oregon. Chet is the founder and former director of NOAA's Climate Program Office, where he led the development and program of competitive climate research efforts. For the first 25 years of Chet's career, he was a research oceanographer and science manager at the Scripps Institution of Oceanography and NASA's Goddard Space Flight Center. During his research career, he regularly published papers on ocean circulation and monitoring and led the development of research satellite missions. As the Department of Commerce representative to the U.S. Global Change Research Program, Chet advanced the growth of climate research across the federal enterprise. In recognition of his accomplishments, he received the Presidential Rank Award for federal senior executives. So now I'm going to turn it over to Susan and Chet. Thank you for being here.
Excuse me, Susan, I think you are muted.
Okay, I think, am I unmuted?
There you go. Now you can, there you go.
Okay.
I can hear you now.
Did I beat Susan to the punch? You want to start it off, Susan?
Sure. Thanks for joining us today as we discuss protecting the planet through climate science, policy, and law.
So, well, thanks. I'll jump in now and good morning, everyone, and welcome back. It's good to be engaged with the college again after quite a few years. Susan and I have developed a four-part program for you this morning, and it's interactive and will include some multiple choice questions, such as the first one you see up on the screen. Where we're trying to learn something about all of you and what you know about global warming already. Do you consider yourself well-informed, moderately informed, or uninformed? And why don't we start off with that, and I'll let Olga set up the poll and just make sure this is working, get our technology set up before we engage on the rest of the program.
I am going to start the session. I am going to start the session off with a quick glitch. Emma, can you hop off this, please? Because there's two of us logged in and now the polling won't work. So if you could leave and then I'll be able to launch the polls. Sorry about that, everybody. There we go. There's always something. Chat, it's not working for me right now.
Okay. Well,
let's have people just put them into the chat. That's the best thing to do.
Sounds good. And then let's move on to the next page. So I'm going to be covering the history of climate science or climate change related to global warming. And we decided to split up this presentation, as I said, into I would talk about the science and help me out here. Susan will talk about the policy and law structure. And we're going to follow a timeline. But first, I want to open up with some latest news. There's obviously been a lot of news in the papers, especially this year, related to climate change with the advent of a new administration and a more open policy towards looking into the problem. What you're seeing is a evaluation of climate statistics that's produced by NOAA every 10 years, looking back 30 years on observations. And the particular slide shows how the climate has warmed in the past 30 years relative to the 20-year average. And you see that it's warming, no surprise, especially in the West. The Southeast tends to be always lagging behind a bit. And it's warmed relative to the 20th century average, about 1 degree or more in the West and other places where it's a dark red. Now, there's options as we go ahead in the future. One option is we really don't do much. And in that case, the way this picture would look 100 years from now, relative to the 20th century average, would be a very dark red, suggesting that the United States had increased in temperature by over 10 degrees Fahrenheit. The other option is to try and do something to control greenhouse gases. And in that case, you would see a more lighter color across the screen, perhaps a few degrees Fahrenheit increase across the United States. So this morning, we want to talk to how we make that choice going down the line, how it's been made in the past, whether or not it's been made, and what the future choices are as we move ahead. And a lot of that will be covered in the talks that follow. But I'm going to start going back to the early history, the 1800s. So if you can bring up the next slide, please, Olga. The sketch of how global warming worked was actually done in the 1800s, surprisingly. In the 1820, Joseph Fourier, a French mathematician and physicist that we may be familiar with for other reasons, wanted to examine why the planet is warm, when if it was just a rock orbiting the sun, it would probably be a lot colder. In fact, if you do the calculation today, it's about 60 degrees warmer on average than if it was just a rock orbiting the sun at this orbit length. And so he postulated that the atmosphere was responsible for keeping the temperature much more moderate. But he didn't understand why the atmosphere made it more moderate. It took Joseph Tyndall, an Irish chemist in the mid-1850s, to examine the various gases that make up the atmosphere to see which ones, if any, actually captured thermal radiation. And he found that the largest gases, by quantity, nitrogen and oxygen, were transparent. But carbon dioxide, water vapor, and methane turned out to be gases that are in the atmosphere and did retain heat and would re-radiate back into the atmosphere. So he obviously picked up on why the atmosphere was warming. And then it took Sven Arrhenius, a Swedish scientist in the late 1800s, to examine the problem. Well, how does it work? And he wanted to look at, could it get cooler if the amount of carbon dioxide in the atmosphere was reduced? And indeed it does by several degrees, according to his early primitive calculations. And therefore he could see some potential reason why you might develop an ice age, which he was most interested. His colleagues, noting that there were a lot of fossil fuel emissions in the cities, asked him to look at what would happen if the carbon dioxide doubled. And then he saw that the atmosphere would warm substantially and lead to a warming effect across the world. But there were still a lot of questions to be answered. So Olga, if you can move on to the next page, please. The next part I want to talk about is the question of where does the carbon go? Because people wanted to know, if you do put these emissions into the atmosphere, would they get absorbed by the ocean? And therefore you really wouldn't see any change, long-term change or warming, or would they retain themselves in the atmosphere? And so Roger Revell took on this problem. He was the director of Scripps Institution, actually, from 1950 to 1964. And he took on the problem in the early 1950s. And by 1957, he wrote an article which said that his research had determined that about 50% of the fossil fuel emissions would remain in the atmosphere. The absorbing of carbon into the ocean was not easy, and it takes a lot longer than people had expected. And he worked out the complexities of how that worked. So the next question was, well, how fast is carbon dioxide growing in the atmosphere over time? And is the problem we should worry about that it's going to happen fairly rapidly, or is it some long-term increase that may not be a problem? And for that, the measurement of carbon dioxide had been proving very difficult for a lot of people. But Beckman Instruments had developed a new instrument to measure the absorption of infrared radiation in a variety of gases. And so he invited Charles Keeling, a postdoc up at the Caltech Institute, who was measuring carbon dioxide around the state of California, and very accurately, and he invited him to join him at Scripps and try to put together a measurement program in 1957. So Keeling joined him, and they started to make the measurements. Keeling decided that the best place to do it would be at the Mauna Loa Observatory shown in the picture, where the air masses over the Pacific should be fairly low in other pollutants. He also placed one down at South Pole Station in the Antarctic. So this program started in 1957, and the outcome is shown in the next slide that you're probably all familiar with. Olga, can you bring up the next slide, please? So what Keeling found, after determining that the jiggle in the line was the seasonal cycle in the Northern Hemisphere, that doesn't show up as much in the Antarctic. The measurements come out about the same in both areas at the time he started making the measurements, around 310 parts per million. And after about 6 years, they were very solid in their results, that carbon dioxide in the atmosphere was increasing, and that the trend was pretty steep. In fact, you could see, if fossil fuel emissions continued to accelerate, you could easily double carbon emissions by within a century. And so, noting this problem and suspecting that this would lead to a major global problem with warming, Revell and Keeling went off to Washington in 1965. And I'll turn it over now to Susan, who will talk about what happened.
Okay, next slide. What we have here is Roger Revell meeting Lyndon Baines Johnson in 1965 in November. Roger Revell, Charles Keeling, who Chet just mentioned, and other client scientists on the White House Science Advisory Board shared with Johnson this trend in increasing CO2 levels and really the implications for the climate. This picture shows Revell meeting LBJ and warning LBJ that the ice in the Antarctic would melt, that sea level would rise, that the ocean would warm and become more acidic, and that plant life would grow faster. Now think about this. Many of us didn't know much about global warming until the 1990s, after the first IPCC assessment. But throughout the 60s, 70s, and 80s, American presidents and Congress knew what was happening. Perhaps because the global effects seemed to belong to the distant future, both Congress and the presidents simply ignored global warming. Instead, they were consumed by the issues of that day: civil rights struggles, urban riots, the Vietnam War, Watergate, of course, the OPEC oil embargo, and then later in the 80s, Wall Street greed. Remember, Bonfire of the Vanities said, "Greed is good." Next slide, please. So the folks in Washington, D.C. Most assuredly knew that global warming was going to change the world. The Earth was warming fast and we would see major impacts soon. Nixon's domestic advisor, Daniel Moynihan, shared this insight with Nixon, warning him that the CO2 level would rise 25% by 2000, increasing the global mean temperature by 7 degrees Fahrenheit and sea level by an estimated 10 feet. Moynihan underscored the impact in these words: goodbye, New York, goodbye, Washington, for that matter. And back to Chuck. Chet.
Okay, thanks, Susan. Yeah, I know we'll get our names straight. We just met each other over the last month and a half, and it's been great to work together on this and actually develop it. You're seeing the first run. This is the first showing of this presentation, so hang in there. I wanted to note that in terms of the history of global warming, there's a terrific book out there by Spencer Ware. It first came out in 2003. It's called The Discovery of Global Warming. And the amazing thing is he's kept the book online, or a lot of it online, and continued to add to it. So I really enjoyed going back and reading it, getting ready for this, because he goes into great detail that many of you may not want to do. But if some of you are interested in the real details or may have been involved in some of this, you'll really enjoy it if you haven't read that book. So we come to the 1970s, and there remains a question. And it is, how warm is it going to get if carbon dioxide does double? It's really not known. The calculations that have been done are primitive. Numerical climate models are still 10 to 20 years away that can really answer this question. So the National Academy in 1979 brings together a group of experts for a week at the Woods Hole Research Center for the National Academy. It's a beautiful house up on the overlooking Quistit Harbor. And I can imagine, I've been there a few times, and they serve a great lobster dinner, which unfortunately I can't enjoy because I'm allergic to it. And I can just see these folks running around the halls there with their red lobster aprons, arguing about the issue of the day, which is how warm is it going to get. And they come up with a final estimate at the end of the week, which is incredible. They propose that the most probable global warming from a doubling of CO2 would be near 3 degrees centigrade globally. Now, it's later learned that land temperatures tend to increase about twice the rate of the global average temperature worldwide. So that over land, that would mean you'd have 6 degrees centigrade of warming. And if you translate that into Fahrenheit, that would be about 11. Like I said, it could happen if we get to a doubling of CO2. You could be up near 11 degrees warming, because this estimate is held up under scrutiny by much more sophisticated models, even up to today's time. So the world takes notice. There's a globalization of science. The UN holds the first World Climate Conference that fall. And it leads to the establishment of a program to coordinate research internationally through the World Climate Research Program under the World Meteorological Organization. And by 1988, the UN, following the work done on the ozone problem, remember there was the ozone hole problem, really got great attention from science in the 70s and 80s, and they established the Montreal Protocol to reduce ozone depleting substances. And along with that, they developed an assessment process that takes place every 4 years and continues to take place. And oh, by the way, on the ozone problem, it's actually working. They are being able to mitigate and demonstrate that they can mitigate through the change of ozone depleting gases to other substances, the reduction of the hole. So the UN decided to set up a similar organization to look at climate change called the Intergovernmental Panel on Climate Change, which would carry out assessments of science for policymakers every several years, looking at the science, but also options for adaptation and mitigation, looking at risk and possible options for solutions. The first assessment was done in 1990, and it came back the science really wasn't that strong at all at that point. I contributed a few images that we were doing, looking at sea level rise from space at the time, and many of my colleagues in the Goddard actually got much more involved with it. But what they did was, at the end of the first assessment, they said the key points were that greenhouse gas emissions from human activities are increasing and can provide additional warming. There will be considerable impact on humankind over time, and the solutions will require a high degree of international coordination. So it's a shot over the bow, really, but not a convincing declaration that humans are the responsible for this warming. You can see in the pictures on this slide the challenges of carrying this work out. At the end of all of the meetings of the science and the development of it and the reviews, the lead scientists shown here, Susan Solomon, who was at the time a NOAA chemist that I knew, and Xin Dai, who was a glaciologist in the Republic of China, they had to meet with over 200 policymakers, climate negotiators, and other delegates from countries, from all the UN countries that were involved, and negotiate word by word, line by line, punctuation by punctuation, the final summary document. And I talked with Susan a few months after this, and when she was all finished with this, and she did it in 2007 with the fourth assessment, but I wanted to show the picture anyways to give you a sense of how it worked. She told me it was the hardest job she'd ever done in her life. She never wanted to do it again. She went off fishing for a few months and ended up as a professor where she now is at MIT. Next slide, please. So the fossil fuel emissions continue through the 1990s. Nothing really being done to suspend it. Susan in a minute is going to talk about the Kyoto Protocol, of course, that was brought up in the mid-time. But I wanted to show this figure that begins to appear in the fourth assessment and later in the fifth assessment, but also the third assessment in 2001. Modeling computer climate modeling had developed substantially by this time. And there's a number of model solutions now being run. At the first assessment, I think it was just the model out of Princeton that Suki Manabe and Kirk Bryan did, a coupled ocean atmosphere model to look at climate change in the past and in the future. But now there's about 50 different models being run by over 30 groups internationally. And they're managed through an integer comparison group that's run through the UN. And they were asked for the assessment to examine in 2001 how well the models could mimic the 20th century climate, in particular the global temperature average. And what you see on this figures on the right in black is the global temperature average, which rises until about the 1940s, then has a decrease, and then rises again substantially from about 1960 to 2000. And then you see some yellow lines in the top with a red line going through it, and down the bottom you see a light blue series of smudges with a dark blue line. So in the bottom, the models don't use any fossil fuel emissions to do the forcing in the models, and they run the model through the 20th century, and they're unable to represent the dramatic warming from 1960 to 2000. But when the models put all the fossil fuel emissions back into the models, then they can replicate the strong rise in temperature in the late 1900s. And that's shown by median of the red line, but the yellow smudge is all the models and all their different results. All of them seem to go in this direction. So it's very convincing information for the IPC, and really brings to a close what Spencer Wirt calls this discovery of global warming. It leads to a very strong statement in the 2001 assessment that it is now the human role in global warming is unequivocal. So I think I turn it back to Susan at this point, and she goes on with the, I'm sorry, we had a question at this point. Are we ready to try the questions? So,
Chad and Susan, unfortunately, the polling isn't working for us, but I just recommend going through the questions and everyone can submit their answers in the chat.
Sure. I raised this question because I've spent a lot of time certainly supporting the development of the assessments and being involved somewhat peripherally, but really hadn't been involved that much. But a number of assessments now get done. They're the IPC standard, which are done for the globe. The US Global Research Program, which was put in law in 1989 and signed by George Bush, requires an assessment for the US every 4 years. And then a number of states have started doing assessments. Oregon does one every 2 years by legislative action at the request of the legislature, starting in 2010. The fifth one just came out, and it's quite interesting for those of you who live in the state. California has done a number of assessments, and the last one was in 2018. And oh, by the way, on the sea level issue that we talked just a few minutes ago, I think Susan was referring to the quote from Moynihan suggesting that sea level could rise 10 feet. The California assessment this year actually includes an outside extreme estimate based on some new modeling from some glaciologists that suggests sea level could rise 10 feet in the coming century, and the state's communities should begin to consider along the coastline, especially rates that might be from 3 feet to 6 feet along the coast. So more about that later. You'll hear that in another talk that's going to talk about coastal adaptation. But what I wanted to refer to the number of assessments that are taking place. And I'm curious with our audience, whether people actually know about them, whether you either helped prepare them, whether you use the information of the work, or whether you're not aware of them or haven't had the occasion to use the information. They're voluminous documents, and more work is going in to make them more interactive and more palatable to a general audience. So let's move on then to the next slide, because I think Susan now is going to take over and talk about the Bush 1, Clinton, and Bush 2 years.
That's right. Even after the first IPCC assessment was prepared, really not all of the public's attention was captured. Americans were still focused really on the pressing issues of that day, fighting the Gulf War in order to protect Western access to Middle Eastern oil, the Republican contract with America, healthcare, and of course, whether Bill Clinton was having sex with Monica Lewinsky, certainly a pressing issue. But really, the world had awakened to global warming at this point, and so there was gradually the momentum building for policies and laws to address it. The development of policy really began with the signing of the UN Framework Convention on Climate Change. And they signed that at the Earth Summit in Rio in 1992. Framework conventions, for those of you who aren't familiar with international law, are essentially international agreements to agree. So they agree on some measures to address an issue, but they don't have any binding provisions. Naturally, the US Senate quickly ratified the Framework Convention, and then the international community really sat down to negotiate a binding treaty. That binding treaty is what became known as the Kyoto Protocol. And as the Clinton administration was negotiating the Kyoto Protocol, the Senate sent him a clear message that said, we're not going to ratify it if you sign it. He nonetheless went ahead and signed it in the hopes that perhaps the political composition of the Senate would be changing in by 2000. About this time, Congress was beginning to consider greenhouse gas legislation to address climate change. The legislative proposals were typically based on a greenhouse gas emission cap and trade system. That's a marketable rights system where everybody has a certain amount of rights, but they can go ahead and trade them to others. So one country may end up controlling more greenhouse gas emissions than another country, but they exchange money or other goods in order to pay that off. Even though EPA had authority to regulate under the Clean Air Act, it didn't propose to regulate. It was like a scene really from Beckett's Waiting for Godot. The Clinton administration was waiting for Congress to pass climate legislation, but unfortunately that legislation really never came. At that point, what the Clinton administration began in earnest was to consider its power to regulate under the Clean Air Act. Both EPA General Counsel Joseph Cannon and then the next General Counsel, who was Gary Guzzi, advised President Clinton and Congress that EPA had authority to regulate greenhouse gases under the Clean Air Act. In the Clinton administration's mind, this meant that the next president, Al Gore, would be able to address climate change, even if Congress didn't act. And Congress didn't act. It has not passed comprehensive climate legislation in the 30 years that have passed since the first IPCC assessment warned us that climate change would change our lives on Earth in dramatic ways. So my question is, why not? And I've got another question for you, and it may take you a little time to think about this, but what is your theory about why it is that Congress didn't do anything about climate change? Next slide. Okay, so A is our political system favors divided government and thus the status quo. B, only Dems care about global warming, and they controlled Congress for only 4 years between 1994 and 2020. C is that environment, including global warming and climate change, wasn't really a salient political issue. And D is that the fossil fuel industry and conservative think tanks used very expensive PR and global we're getting some good results already. Used PR campaigns to convince the public. So let's see, we're getting C and D, all of the above, B and D. We're getting some interesting results. All, D and C, B, maybe C, all of the above. Okay, so if you go to the next slide, I happen to be of the opinion that all four theories are right, but I wanted to expand on the fourth theory just a little bit, because I had a number, well, I guess I should do full disclosure. I represented the oil and gas industry as well as the mining industry in the beginning of my practice in the 80s. And so I'm not only very familiar with the the industry, but also very familiar with the way they operate and how good they are at public relations. They basically collaborated, I guess is the nice word to use, on trying to convince the public that there was no need for climate change. Their campaigns really sought to create the impression that there was great uncertainty about climate science. And go back to that quote from Moynihan. He told Nixon that the process is really pretty simple and we pretty much understand the basics. You know, the details are different, but so they knew that wasn't true. That reducing greenhouse gases was extraordinarily expensive, and of course the Stern Review told us that wasn't true, and oh, by the way, that climate change, the adaptation that was going to be required was going to be vastly more expensive, that the demand for fossil fuel energy and the consequence of global warming was just a matter of our choices, our individual lifestyles. And surely we didn't want to change our lifestyles, right? And then, of course, the wonderful classic claim that carbon dioxide is just natural. It's just part of the way life works. And they had an ad that came on at roughly the same time as Inconvenient Truth that had a young girl blowing, you can see that picture, blowing on a dandelion. And what the ad said was, carbon dioxide, they call it pollution, we call it life. So just like any other advertising campaign that equates smoking cigarettes or drinking alcohol or driving fast cars with sexual attraction, we bought it. We bought it hook, line, and sinker, even though there had been a great deal of consensus within the scientific community. They convinced us there wasn't. They convinced us it was very expensive to reduce greenhouse gas emissions, that, oh, by the way, we'd have to give up our lifestyle. And it's just a natural thing. Okay, so next slide. Fortunately, not everybody believed that. And so while the federal government was fiddling around as the earth burned, doing nothing, the states, mostly blue states, began to take charge on climate change. Next slide. The states passed clean electricity standards that are known as renewable portfolio standards. Iowa was first way back in 1983. That's a long time back. That's before the first IPCC assessment. New Jersey was the second in 1991, about the same time as the first assessment. And then 5 other states joined in from 1997 to 1999. Those are Connecticut, Maine, Massachusetts, Nevada, and Wisconsin. The the term renewable portfolio standard may not just sort of resonate with you as meaning clean energy. And the standards were known as renewable portfolio standards. And because that allowed the states to be agnostic about global warming, because even among Republicans, renewable energy was desirable for the purposes of energy independence. And at the time, we were worried about the prospect of peak gas and peak oil production in the United States. So we saw ourselves as perhaps drifting into a situation where we would be back, as we were in 1979, in an oil embargo by OPEC with insufficient gasoline and lines that went several blocks in order for people to get gas. So that's what those Republican states were looking to prevent. Next slide. States also started a little later in the 21st century to adopt comprehensive greenhouse gas reduction strategies. Maine was the first. They adopted one in 2003. California, unsurprisingly, was next in 2006, and then other states followed along. And you can see how we've got the group of West Coast states and the group of northeastern states that go ahead and regulate greenhouse gas emissions. Next slide. The states realized if there wasn't going to be a federal solution, that they needed to band together on a regional basis for several reasons. The first was to avoid undercutting each other for economic advantage. In other words, to avoid a race to the bottom. But they also needed to band together to create robust greenhouse gas emission networks. One of the things I did when I was writing my master's thesis in public policy was study what it takes to have a well-functioning pollution market. And it takes a lot of trade possibilities. That's the main thing we need, is liquidity and marketable rights network. And so that meant that in order to get enough transactions or trades, the states really needed to band together. So both the northeastern states on the East Coast and the West Coast states indeed created regional agreements to cooperate on greenhouse gas regulation. Although the states in the middle of the country have been a little bit late to the dance, you can see that there's a lot of green on this map, and all of that green really says that they've taken some steps to move towards clean energy, with the exception of Appalachia, the Deep South, and those good old iconoclastic, rugged individualism western states of Alaska, Idaho, and Wyoming. Other than those folks, every state has taken some action to address greenhouse gases. If you're looking at the map closely, you'll notice that I've forgotten Nebraska. And frankly, don't ask me to explain Nebraska. I don't understand that. Maybe someday I will. Next slide. apart from seeking state regulation of greenhouse gas emissions at the beginning of the 21st century, climate activists and state and local governments resorted to the courts. They filed literally thousands of lawsuits to force government action to address global warming and to assess damages against power plants and the oil and gas industry for the impacts of climate disruption. Next slide, please. In the last decade, young people from around the world have mobilized. Greta Thunberg is the one that we remember, but the young people have brought lawsuits to force governments across the globe to take stronger action to reduce global warming. The lawsuit, Juliana v. U.S., the lawsuit against the U.S. government, was brought by some young people and litigated by lawyers from Our Children's Trust here in Oregon. That case raised many claims, including a claim known as substantive due process, a claim that the young people were being deprived of their fundamental right to have a climate that would sustain human life. They also claimed that the government owns the air, holding it in trust for the public, and that this public trust is being violated by government actions that encourage use of fossil fuels, like selling coal, and by the government's failure to reduce greenhouse gas emissions. For a brief time, it appeared that the kids had won. The federal trial court judge, Ann Aiken from Eugene, decided that both of those claims should go to trial. But the Ninth Circuit interfered with the trial by hearing an interim or interlocutory appeal sort of before the trial, and the Ninth Circuit decided that that case should be dismissed on standing grounds. Not because the kids didn't have an injury, but because the federal courts couldn't remedy that injury. Their injuries were deemed not redressable by the courts because it was beyond the power of courts to order, design, supervise, or implement the plaintiffs' requested remedial climate action. The Ninth Circuit said any plan would require complex policy decisions that were entrusted to the executive and Congress. So we never got to the merits of those claims. And as a whole, lawsuits in the United States just haven't produced huge results. All of those thousands of lawsuits. There are two types of lawsuits that are still sort of viable. The first type of lawsuit is the request by municipalities for damages that are for the cost they are going to incur and are incurring to adapt to climate change. And then there are the lawsuits that try to force actions that are already required under existing laws, such as the Clean Air Act and NEPA. We haven't had much success, but I can't leave that issue of lawsuits without noting. Lawsuits in other countries have been more successful. In December 2019, the Dutch Supreme Court decided that the inadequate government action by the Dutch government violated the human rights of Dutch citizens, and the court imposed a legally binding target and deadline for the government to reduce greenhouse gas emissions. They required at least a 25% reduction by the end of 2020. Similarly, just this April, the German Constitutional Court held that the German government has violated the constitutional rights of Germans by enacting insufficiently protective climate laws. Also, last week, the Australian Federal Court held that the Federal Environment Minister has a legal duty not to cause harm to the young people of Australia by exacerbating climate change. This was in the context of approving coal mining projects. But a real breakthrough may have come last week in what has been hailed as a landmark decision. A lower court in the Netherlands ordered an oil and gas company, Shell Oil, to cut emissions from their products by 45% before 2030. So the key here is that the court has directed relief against the polluter, not the government. Next slide, please. Well, coming back to the United States, I wanted to point out that we spent the entire decade of the 2000s after there was a clear statement that it was human greenhouse gas emissions that were causing the global warming problems, trying to get some sort of federal regulation. Remember, Al Gore didn't become president. Al Gore may have won the popular vote, but he didn't become president because of the hanging chads in Florida. But at the time, that didn't seem to matter all that much from the viewpoint of climate, because George W. Bush had supported regulation of greenhouse gas emissions during the 2000 campaign. And indeed, EPA under the Bush administration initially supported greenhouse gas regulation, but Dick Cheney, and we remember the Cheney name now because of Liz Cheney, who has stood up against Trump, but Dick Cheney also is from Wyoming, and he was able to successfully reverse George W. Bush's position on that, putting really an end to both the possibility of bipartisan legislation as well as Clean Air Act regulation in 2003, which is when EPA denied a petition for regulating greenhouse gas emissions from vehicles. That turned out to be a very important little petition filed by this little 3-person NGO. The DC Circuit, when they challenged the EPA decision in court, affirmed the EPA. But then in what may be really the surprise of the century, and maybe the most important case of this century, the United States Supreme Court reversed EPA and required EPA to decide whether or not greenhouse gas emissions posed a threat to public health and welfare. It's worth noting, and that very long oval on the timeline is an indication that for 2 full years, the Bush administration declined to make that endangerment finding, using every device possible. ultimately, it was able to avoid making an endangerment finding during the Bush administration. They even went to the extreme of OMB refusing to open an email from EPA that contained the dreaded endangerment finding. That OMB could say until they had opened the email, they hadn't received the endangerment finding. That sounds like a lawyer talking. Okay, so next slide.
Pardon me, I'm gonna pop my head in real quick. We're at the top of the hour, so we have about 30 minutes left in our time for this course. So I wanna make sure that we have some time for Q&A. So if we can wrap things up maybe in about 5 minutes, we'll be on our timeline.
We will we will.
Okay,
Okay, so this is Massachusetts v. EPA. It opened the floodgates for regulation, and while the people were regulating, it was time for the scientists to be doing their work. Next slide.
Great. Thanks, Susan. Well, meanwhile, the world continues to get warmer. And at the end of this was at the end of the fourth assessment, and you can look at the sea ice, the opening of the perennial sea ice in the Arctic, and the increase in shipping, which you can monitor through the Arctic Council, has shown that shipping has been increasing rapidly over the years, unfortunately, because it's a very vulnerable area. Sea level continues to rise. Next slide, please. And now sea level now is measured both from satellites and from tide gauges, of course. And there's a very interesting paper that just came out to look at the causes of sea level at various points along the curve. But most interesting is that a rapid acceleration now is seen in the last 20 years based on a lot of satellite evidence and ground truth with tide gauges. And the rise is essentially doubled from the overall rise between the 1900s, but recent research is showing that there may be a reason for the pause in the 60s. Next slide, please. I wanted to talk just a second about using climate information to help decision makers. And I think I won't spend much time on this because I think you're going to hear a lot about it as we talk about wildfires and coastal adaptation. Certainly we'll hear more about the polar regions from the Office of Polar Programs from NSF. But in 2009, the third World Climate Conference was held, World Climate Conference #3, because obviously you didn't want to call it a third world conference. And it focused on climate services. And I had a chance to help out with the organization at that conference, and it led to a framework that was ratified by over 60 countries to help transfer information among all nations, but certainly from the developed world to the developing world, which didn't have access to a lot of the observation systems, the global observation systems that were coming online and showing all these incredible impacts that were happening from the warming, as well as techniques and things like that, that they could run through their hydromet services within their countries. I do want to talk for a second about integrating federal systems to look at particular issues, in particular drought. Talk about the next slide. And just briefly, NOAA was asked to set up an integrated drought information system in 2005, which we did. And one of the products that was developed actually by the University of Nebraska in the 90s, but has been held on remarkably well and been an incredible early warning system, is the Drought Monitor. And this information just shows the exceptional drought that's showing up in the Colorado Basin recently, and has led California to begin to consider possible restrictions on water use. It's basically a warning system with about 5 different categories. You can read more about it at drought.gov. Why don't we go along to the next slide? Obviously, it's time to take action. When President Obama came in, Jane Lubchenco, who was the administrator of NOAA, talked with an idea that we were pushing around within NOAA was to set up a separate National Climate Service within NOAA to facilitate this transfer of information to decision makers. Unfortunately, it got shot down in the Congress, as you might expect, but it did make its way all the way through the executive branch and into the Congress. And essentially, it was using the word climate on anything seemed to be bad news. In Congress, no matter when you went in over those years. So let's move along, and Susan can tell us more about what's going on.
Okay. Basically, we have three eras. The Obama era, where there's a lot of climate regulation that occurs, the Paris Agreement occurs. Then there's the Trump administration, and then finally the Biden administration. Let's go on to the next slide. We had two presidential administrations that responded very differently to the fourth assessment. This is Obama's whole of government approach, and it regulated lots of things, fuel economy, power plants, oil and gas operations. But most of all, what was happening in Obama's era is that there was a lot of research and development being done. The one thing that fossil fuel industries couldn't stop was innovation, driven by government subsidies. And so the scientists and engineers made clean energy, wind, solar, and EVs cheap. Next slide. This just shows you basically that wind and solar are now, and have been since 2014, superior sources for electricity in terms of unsubsidized cost. And we also learned how to deal with the intermittency of wind and solar through storage and grid improvements during the Obama administration. Then along came Trump with his determination to undo everything. Indeed, he never met a greenhouse gas emission he didn't like. It's kind of like insurrectionists. They're good people. Next slide. Okay, and next slide. That's Trump. Next slide. The list of things he reversed. Next slide. The states responded to Trump by strengthening their climate policies. Next slide. And so we hit the future of climate law and policy with really not very much time to talk about the future. Where do you want to go from here, Chet?
I'd just like to show the question I have, because I would like to see if we could get some feedback on how people feel about where the future is headed. As I pointed out, there seems to be a couple of cases coming down. Either not much is done and warming gets considerably stronger over the century with dramatic irreversible impacts. Move along, if you could move a couple of slides to the question, Olga, that would be great, right there. So what I'm asking you is, what scenario do you think is most likely in this century? Either you're very worried that this extreme case might happen, you're pessimistic that maybe somehow the nations of the world can come to a stabilization of fossil fuels, which would lead to this 3-degree centigrade global warming, or you're optimistic that maybe we can actually constrain things, maybe even learn how to do carbon capture and storage and reduce it to only 1.5 to 2 degrees, which is what the UN is really shooting for, but it looks, there's a lot of pessimism about doing that. Or you're overly optimistic And either you don't believe any of this, or you think there's going to be some tremendous innovations in technology, as Bill Gates suggests, and we're going to be able to get control of the climate system and perhaps keep it well below 1.5 degrees. And that's item A. So I'll leave that to you. It looks like there's a lot of fascinating discussion going on, as I would have expected on the chat lines, but I can't read. So look forward to getting that in the Q&A. So now Susan can just tell you briefly some of the policies that Biden is thinking about, is trying to get pushed through, the things he wants to do, so we don't get to that those pessimistic or worrying.
So one thing you have to understand is that it isn't as simple as reversing Trump's reversals. Next slide. Biden has a whole different level of ambition. Next slide. The issue has gained salience, and so we really have presidential attention to this at this point. Probably for the first time, the concentrated attention it deserves. Next slide. Biden started by signing a climate executive order. Next slide. But his real approach is the American Jobs Act that is currently being negotiated between Biden and the Republicans. The hallmark of his strategy is to take issues that people care about more deeply than climate, like family wage jobs, racial injustice, replacing critical infrastructure, and put that caring in behind the force of climate legislation. Next slide. So really what we've got here is him bringing all of these rivers together. It's a confluence of forces that he hopes to harness on behalf of the climate. Next slide. He's using a whole of government approach. He's relying on spending more than regulation, and he's trying to tax the super rich to avoid deficit spending and address income inequality. Next slide. He's hitting all of the important sectors, except contrary to rumor, you can still eat beef under Biden's proposal. Next slide. This is the legislative vehicle that for Biden's climate legislation. Most of it, all the black is funding. The green is regulation. And as it stands right now, we are looking at trying to get an infrastructure bill through that is a funding bill, not a regulatory bill. And so what we're going to see is hopefully a bipartisan deal on infrastructure that is strong enough to do what needs to be done on that score, and then executive action under existing statutory authority to do the rest. Near as I can tell, everything that needs to be done, there is legislative authority that can be used to regulate already. So that's what I see for the future. And with that, I think we're to comments and questions.
Thank you so much, Susan and Chet. So we've been gathering some of the questions from the chat bar. Feel free to add some new ones here. One of these goes way back to the beginning of the presentation. Bev Carplus Heartline asked, and I think this would go to Chet, for the Southeast, why is the Florida Peninsula and Texas coast dark red while the rest is paler to average?
Well, that's a really interesting question. I don't really have an answer for you. And it'd be a good thing to explore further. Sorry about that. it was cooling at one point, and then it's been warming. And I'm not sure how much well it's been understood. So anyways, I'm sorry I don't have the answer for you readily, Bev.
So Dave Baxter asked, Chet, can you comment on how the opacity of the atmosphere has changed over the last several decades? As an amateur astronomer, I fight light pollution, but I wonder how much the difficulties I experience are more due to problems with CO2 emissions. I
don't think so. I think, well, it depends on what wavelengths you're looking at, but if it's optical, I think it's more, would tend to be aerosols. There is a group at NOAA in Boulder at the aerosols lab that has been looking at global dimming and trying to measure it over a long period of time. And I'd suggest you contact them. I don't know, I haven't really kept up with their latest results over the last decade, but it's a good place to go. I'm sure it's a concern of all astronomers, and that's a good group to start with.
Okay, thank you. Let's see, we have Bev again asking, why is it a near-term or long-term win for anyone to convince the public and ignore climate change? And maybe it's a rhetorical question, but I do think it's a valid one.
Well, go ahead, Susan. That's a good one for you.
I think that they believed that they could fully exploit the existing resources and simply make a lot of money quickly before they needed to pivot. And Exxon was one of those dinosaurs that didn't ever see any reason to be out ahead of the pack. They wanted to be at the end of the pack. And it was really their strategy that was driving everything.
Chet, do you have any thoughts on it?
No, nothing further. Thanks.
Okay, thank you. Catherine Radica, I don't know if I'm saying your name correctly, I'm sorry if I didn't. What do you see as the role of government in fostering the innovation we need, especially in basic research and demonstrating scalability?
That's a great question. Having been in government a bit, there are some programs that foster innovation. For example, NASA had a discretionary award to its scientists that was a very high risk. There's also small business initiatives that are done for research. So that's on a small scale. I think there's a general sense overall on the energy side of the equation that it's really underfunded. Research on developing new techniques and to really tackle this problem, change the energy system of the world essentially, is really underfunded. A lot of techniques and innovation is just not being fostered strongly enough in the government. And I think if you read Bill Gates's book, he goes into some of that. He would really like to see the marketplace stimulated to develop new ideas. He felt that innovation was going to be the key to the future.
Thank you, Chet. Alan Ridley, former Clean Cities Coordinator and San Diego Region Clean Cities Coalition, asks, how can we ever begin to take the profit out of fossil fuels and with it their clout to influence the American public to buy bigger SUVs and drive faster?
Yeah, great question. Susan, you want to take a crack at it? I've got something to say on that too.
Sure. I think the lawsuits that are happening around the world are exactly aimed at taking the profit out of it. I think the other thing that is happening is investors are starting to rebel with respect to the oil and gas industries backwards approach to climate change. We saw it in the Exxon shareholder meeting where engine number one, the hedge fund with 0.02% of the shares, was able to get 3 seats on the Exxon board. And I think there are a whole series of forces that are right now coalescing. It is clear that in order to compete with the Chinese that we are going to have to get out ahead of this. We need to be the innovators in clean energy, in EVs. And so I think good old American exceptionalism is going to come in here. And out of pure competitiveness with the Chinese, we're likely to do a lot of funding of research. Certainly that's Biden's budget proposal. And we're going to go ahead and try to compete with the Chinese. That means competing for world opinion. And there's no doubt that world opinion has regarded us as backwards. And so this is a critical change to have us be competitive. I think that's going to drive a lot of Republicans ultimately to do the right thing on this.
So Susan and I went
Thank you,
back and forth a
Susan.
little of this, that I said, you know, on the one hand, you read Bill Gates's book, and he does talk about the need for innovation, looks at pricing to bring down the prices of renewable and green technologies, if you will, that'll facilitate solutions to the problem against what's happening in the fossil fuel industry. And then I told her about reading Daniel Yergin's latest book. He's an expert on energy policies, especially on the petroleum industry. And he wrote a book about the new map and who's in charge in fossil fuels. The United States is right at the top of the list. We're energy independent. We've got cheap gas and oil. Of course, they're subsidized. But he does a very poor job talking about a transition out of leadership in fossil fuel production by the US into some green technology and green energy solutions. And it's a real disappointment. And critiques of his book say, you know, it's a real disappointment. He really didn't address the political issues and the concerns of the populace to change all this.
Thank you both. So Kellen asks, what do you think about the argument in Michael Moore's documentary, Planet of the Humans, that renewables were never going to save us and that we need a reduction in activity akin to what we experienced during the pandemic? This argument is based on the high cost of manufacturing of components for renewable energy and the short lifespan of these same components, meaning renewables do not produce excess energy in the way we believed.
Well, I don't believe it. I'm familiar with the life cycle costs of clean energy, and what's really clear is that we get a lot of reduction of greenhouse gas emissions by adopting clean energy. Obviously, anything that includes building something means that you're going to have some greenhouse gas emissions, but the sector that is most problematic is industry in terms of steel, iron, and cement. But in all of those industries, we're to the point where we should be able to use clean energy to do that manufacturing, which then reduces the life cycle cost of green energy, including EVs and all of that. So I think he's fundamentally wrong about the economics. And I did study economics under Carl Stevens, so I have some confidence that I can figure that out. He's just wrong.
I don't really keep up with that much. I thought the book by Bill Gates was one of the first that I had read, and I don't read much in that sector, that really tried to look at the pricing issue of all sectors of the economy and how they could essentially go to a net zero emission portfolio. It's really challenging. There's no question about it, and certainly requires a lot of innovation from his perspective. I will say this on the manufacturing side, that a group of us in Washington were invited to meet with Mittal Steel North America in 2008, I think, where they were actually considering taking on the electrolytic development of of steel. I can't remember how it's actually done, but there is an electrolytic method that takes away a lot of the use of greenhouse gases, development of coke and the heating, et cetera. I don't know what happened with that, but it was interesting that they were interested. I often found that a lot of industries in all different sectors were trying to figure a way around this problem without a lot of help from government guidance or help in developing innovation.
Thank you, Susan and Chet. I've got another question here from Julia Meltzer, class of 02. Susan, could you talk a bit more about insights and the perspective you've gained from working with and defending the oil and gas industry?
Well, the oil and gas industry is obviously remarkably well financed. And so that means that they can litigate anything just about forever. It will take some strong leadership from the Biden administration to go ahead and defend the greenhouse gas emission regulations under the Clean Air Act that need to be promulgated. And Justice will have to go ahead and make the case to the DC Circuit that we can't afford to delay these regulations. That's what industry will be trying to do, is delay. And the government's going to have to really stand firm and probably reverse course from a lot of the positions that were taken during the Trump administration. I don't think Biden will have any problems with that. And so I do believe that they will take the necessary positions to get regulations not only on the books, but actually effective. The thing that has been remarkable in my mind is not just that the cabinet and sub-cabinet positions are so diverse, but really that the quality of the resumes of those people are just astonishing. These are people who can get things done, and I've been very pleasantly surprised by Biden's appointments.
Well, thank you so much. I know we had a couple more people ask some questions, but we need to wrap things up. So I want to thank everyone for being here, and thank you so much to Chet and Susan for taking the time to share your knowledge about climate change history, policy, and law, and for kicking off the program. We had a comment from an attendee about the best way to connect with others who are attending Alumni College. There are two ways you can do that. You can join our discussion session at the end of today, and if that doesn't work for you, and then that session will be at 4 p.m. Pacific. We encourage you to also post a message in the messages and posts section on the event platform Socio. And if you have any questions about how to use Socio, let us know and we'll get you oriented. So next up, in about half an hour at 11 a.m. Pacific, Kate Mangoya from class of 2008 will be talking about the intersection of racist housing policy and climate change. And then at 2 p.m. Pacific, we'll be learning about coastal adaptations from Rennie Myers, class of 2015, and Nikhil Anand, class of 1998. So if you can find all the links to these sessions, as well as some great reading lists in the Socio app, our event platform. Explore that full program, plan out your own agenda, and connect with Readies on that app. And I look forward to seeing you all in the next session. Thank you so much.
Thank you, Amy. Hey, what came out of our polls? What happened?